All right, let's look at this lesson. First, we are going to look at this equation on modeling linear inequalities. It says, David has 2 jobs. He earns $8 per hour babysitting. Okay, so $8 per hour babysitting. Plus, he earns $11 per hour working at the coffee shop. So B will be hours babysitting, and C will be hours at the coffee. Okay, then it says write an inequality to represent X the number of hours babysitting and Y the numbers at a coffee shop. Ooh, I can't use my letters that I wanted to use. So let's erase the key. This is why I should have continued reading. They want me to use X for babysitting and Y for the coffee shop, that he will need to work to earn a minimum of $200. Meaning he could have 200 or he doesn't mind if he has more than 200. It says David worked a total of 15 hours at the coffee shop. So Y equals 15, so I can replace that with 15. So I would have 8x plus 11 times 15 is less than or equal to 200. And they want me to see how many full hours would he need to work at babysitting to reach the 200. All right, well, let's see. 11 times 15 is 165. So far he already made $165. We're going to subtract 165. That means in babysitting, he needs to make the $200 minus $165 that he already has. He needs to make back $35. He's going to get $8 an hour. So 35 divided by let me put this as a fraction. Alright, 4.375, which means he needs to work more than that, so he has to work 5 hours babysitting. Alrighty. So today we are going to write and solve systems of inequalities by graphing and interpret their solutions. Let's look at this first one. In the graph y equals negative x, which quadrant is completely shaded? Remember, for quadrants, this is 1, this is 2, this is 3, and this is 4. So let's see this. My y-intercept is 0, and then I'm going down, so it's going to look like this. It's a solid line because it's less than or equal to, and because it's less than, that means I'm going to shade below, and the only one that's 100% shaded is quadrant 3. We should never say quadrant 1 because that's not shaded at all, but then quadrant 2 and quadrant 4 are only half shaded. So our answer would be quadrant 3. Alright, let's look at this one. Which ordered pair is not in the solution set? Ooh, so these are all my x's, these are all my y's. Let's try the first one. Y would be 4 is greater than 2 times my x, which is 1, plus 1. 4 is greater than 2 plus 1 is 2 plus 1. 2 times 1 is 2, plus 1 is 3. 4 is greater than 1, so that works. So that is in the solution set. Let's try number 2. Y is 1, and y is 6, I meant. Y is 6, I meant, which is greater than 2. X is 1, plus 1. 2 times 1 is 2, plus 1. Is 6 greater than 3? It is, so 2 is not going to be our answer. Let's look at answer choice 3. Y is 8, is greater than 2, x is 3, plus 1. 8 is greater than 2 times 3 is 6 plus 1. 8 is definitely greater than 7, meaning that 4 has to be our answer choice, but let's just try it. Y is 5, which is greater than 2 times 2 plus 1. 5 is greater than 5. No, it is not. 5 is equal to 5, so it would be answer choice 4. All right, let's look at this one. Which point is a solution to the system below? All right, we're going to have to plug in all the points. So for the first one, 2 times y is 1/2. Is that less than negative 12 times 1 plus 4? Well, 2 times 1/2 is 1, and then negative 12 times 1 plus 4. Negative 12 times 1 plus 4. That would be negative 8. Is 1 less than negative 8? No, it is not. So 1 cannot be our answer. All right, let's try answer choice 2. 2 times y is 6 is less than negative 12 times x, which is 0, plus 4. 2 times 6 is 12. Negative 12 times 0 is 0, plus 4 is 4. 12 is not less than 4, so that's not our answer. Let's try number 3. 2 times our y is 5 is less than negative 12 times my x, which is negative 1/2, plus 4. 2 times 5 is 10. Is that less than negative 12, negative 1/2, plus 4? 10. Is 10 less than 10? No, it is equal to. So the answer is going to have to be number 4, but let's just see why. 2 times the y here is 2 is less than negative 12 times negative 3 plus 4. 2 times 2 is 4. Is that less than negative 12 times negative 3 plus 4? 4 is definitely less than 40, so yes, that is true. You would also want to check the second one to make sure it's correct, but because we already eliminated all the other choices, that has to be the correct one. All right, let's look at this question. It says, the Real Good Cinema is conducting a mathematical study. In its theater, there are 200 seats. Adult tickets cost $12.50 and children's tickets cost $6.25. The cinema's goal is to sell at least 1,500 worth of tickets to the theater. Write a system of inequalities that can be used to find the possible combinations of adult tickets and children's tickets. All right, they only have 200 seats. If they only have 200 seats, that means however many adult and children's tickets they have to sell has to be less than or equal to 200. Then they know that the adult tickets are $12.50, which we said adult tickets are X, plus the children's tickets are $6.25. And if they want to make at least 1,500, that means they want to make more than or equal to 1,500. All right, let's graph these. To graph these, I'm going to need to make them y equals. So first here, I'll subtract the x. This will give me y is less than or equal to negative x plus 200. Meaning I'm going to need to start at 200. And then I'm going to go down 1 to the left 1. Down 1 to the right 1. Down 1 to the right 1. Alright, now I'm going to connect these points and a solid line and then shade below. So I'm going to shade below. Alright, let's look at this next one. I need to make it y equals. So I'm going to subtract the 12.5x. Subtract the 12.5x. That will give me 6.25y is greater than or equal to negative 12.5x plus 1,500. Now divide by 6.25, divide by 6.25, divide by 6.25. We get y is greater than or equal to negative 12.5 divided by 6.25 is negative 2. So negative 2x plus 1,500 divided by 6.25 is 240. All right, this means I'm going to start at 240. And I'm going to go down 2 to the left 1, to the right 1, down 2 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 to the right 1. Alright, it's equal to symbol, so I'm going to put a solid line, and it's to shade above. So I'm going to shade above, meaning this right here would be my solution set. And it says, label the solution set with an X and graph it, and we did that. So all those numbers inside that little solution set and on the solid line are answers to how many tickets would be allowed. Alrighty, let's look at this next example. So we got that answer. It says, Martina claims that selling 30 adult tickets. So let's go to 30 adult tickets right here. And 80 children tickets, which is right here. Let's connect the points. She claims that that would be enough for the goal. Explain whether she is correct or incorrect. Incorrect. Because 30, 80 is not in the shaded section of both inequalities. All right, let's look at another example. The sum of two numbers x and y is more than 8. So x plus y is more than 8. Not equal to 8, it's definitely more than. All right, so let's graph that one first. Let's subtract the x, we get y is greater than negative x plus 8. We're going to start at 8. 1, 2, 3, 4, 5, 6, 7, 8. And we're going to go down 1 to the right 1, down 1 to the right 1. This is going to be a dotted line, and we are going to shade above. All right, and now let's look at the next one. When you double x, so 2x, and add it to y, the sum is less than 14. All right, subtract 2x. We will get y is less than negative 2x plus 14. So let's start at 14. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right. Go down 2 to the right 1, down 2 to the right 1. Perfect. And this again is going to be a dotted line, and we are going to shade below the line. Meaning that this little section right here would be our things. And it says, Kai says that 6, 2, 1, 2, 1, 2, 3, 4, 5, 6, 1, 2. 6, 2 is a solution to the system. Determine if he is correct. He is not correct because 6, 2 falls on the dotted line, which is not included in solution set. Alrighty, now let's look at this next example. Is buying plants and soil for her garden. The soil costs $4 per bag. So we could say 4 times x for the soil. X is the soil. And the plants cost $10 each. So plus $10 for the plants. She wants to buy at least 4 plants. So she wants her plants to be more than or equal to 5. And she cannot spend over 100. She needs to be less than or equal to 100. Write and graph a system of linear inequalities to model all possible solutions. Alright, let's first start by graphing y is less than or equal to 5. This means that I'm going to start at y is 5, which is right here, and I'm going to put a horizontal line through it, and it will be a solid line since it is equal to. And it's greater than, which means I'm going to shade below. Alright, now let's rearrange the other equation. Minus 4x. I would get 10y is less than or equal to negative 4x plus 100. Divide by 10, divide by 10, divide by 10. I will get y is less than or equal to negative 2 over 5x plus 10. Alright, go to 10. And now we're going to go down 2 to the right 5. 1, 2, 3, 4, 5. Down 2 to the right 5. 1, 2, 3, 4, 5. Down 2 to the right 5. 1, 2, 3, 4, 5. Down 2 to the right 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, and then that's equal to, so I could put a solid line. All right, and it's less than, so I'm going to shade below. And this would be my solution set right here, the shaded in section. Alrighty, and that wraps up our lesson on graphing linear inequalities.